All right, so here we go, number 8. We were given negative 12 over y is equal to y minus 7, right? What's always our goal? Our goal is always to get like denominators, right? Correct? All right, but on that right side, we don't have a denominator at all. Do you guys agree? What is their denominators? What are their denominators? That's horrible English. Their denominators are 1. All right, so let's put 1 under there. If they both have like denominators, can I write them as 1 numerator over 1 denominator, folks? Okay? And we're kind of getting into good habits of doing that, because that is preparing us for trig. And now what? I have a fraction equal to a fraction. Bells and whistles. Why do I say that? I can cross multiply because I have a proportion. Yay! Folks, proportions will make your life proportion. Yay! Cross multiply. I mean, that's easy enough. Negative 12 times 1 is negative 12. And then y times this quantity. Now, some of us, and I say this with love, some of us don't like to show our work. And I say this with love. You need to, because you're making careless mistakes. And I want to go, what are you doing? Okay? I want to knock you in your head, because you know better. But distribute. That's kind of like a pitchfork there. Negative 12 is equal to y times y is y squared. Y times negative 7 is negative 7y. Folks, I've got a quadratic equation. What do I do now? Bring the 12 over, and I've got that equation equal to 0. And I can solve it. Do I know 2 factors of 12 that when I add give me 7? 3 and 4. Are my signs going to be the same or different? Same. They're both going to be minuses. So that means my solutions are 3 and 4, correct? Yeah? Now, don't we have to go back and check? Go back and check. We think our solutions are 3 and 4. Check them in. Lindsay, will you cut my calculator on? Let's go back and check. What were our solutions? Negative 4, negative 3? 3 and 4. 3 and 4, 3 and 4, 3 and 4. All right, here we go. Negative 12 divided by 4. Ooh, negative 3. What number did I plug in? 4. What's 4 minus 7? Hey, they match. Is 4 a solution? Yes. Do the same thing with 3. Negative 12 divided by 3 is negative 4. And then 3 minus 7 is negative 4. Do they match? Yes. Do I keep both solutions? Yes. Unless you only have 1, but I have 2. And you could have graphed that problem as well. No. I checked the left side of the Quentin, I checked the left side and then I checked the right side. Okay? And that's why I had 2 of those there. Any other questions? Did that help? Did you find your mistake? Yeah? All right, and then number 9. And then there was 9. Number 9, there's really no nice way to do this problem, I don't think. 15 over x plus 9x minus 7 over x plus 2 equals plain old 9. All right, now I think I just maybe, all right, I'm going to try to become a forest person, okay? What's the easiest way for us to solve these rational equations? If they're in the form of a what? If they're in the form of a proportion, one fraction equal to another fraction, That's a whole lot easier to solve. Do you guys agree with that? Okay. I am forcing myself by, y'all have fun with those straws and oranges. Okay. Proportions. Easy. All right, I'm forcing myself to be a forest person right here, okay? Because y'all know I want to tear that thing up and go tree on it, right? Because I want to find the common denominator, multiply to the top, multiply to the bottom, la, 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 la. But is there anything that I could move from the left to the right so that I could make it easier on me in the long run? I want to try to get a proportion, a fraction equal to a fraction. Is there anything? So y'all are like, what the crap are you talking about? That's the looks I'm getting. Except you're not really saying that in your head. You're going, beep, 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 beep. You sound like Morse code right now. That's what your faces are telling me. What could I do? Think forest, people, y'all. Think forest. Think big picture. What could I do so that I could have a fraction equal to something that's going to be easily manipulated? Sarah. Could I move 15 over x? Folks, if you didn't do this problem this way, I want you to write this down, okay? If you didn't do it at all, I want you to write this down. If you don't care, I still want you to write this down, okay? Beep, 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 beep. I'm back at you. All right, here we go. Subtract 15 over x. Check this out. Because what's the denominator of 9, y'all? 1. Come on now, we can do this. I just went into baseball mode. Uh-oh. You heard it, didn't you? You heard it. All right. 9x minus 7 over x plus 2 is equal to 9 over 1 minus 15 over x. What would you rather find a denominator of? That first line, left side, or this line, right side? What would the common denominator be of the right side, y'all? X. That would be pretty simple. 9x minus 7. Keep in the back of your head, what is she doing? She's trying to get a proportion so she can cross multiply. That's what I'm doing, okay? And I want to have x as my denominator. Well, folks, if x is now my denominator of 9 over 1, what's my new numerator? It's 9x, isn't it? Isn't that the new numerator of that first term? Check this out. Do I have to do anything to 15 over x? No. It stays the same, and now, ding, 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 I have common denominators. What can I do to the numerator of the right side? Combine them. Combine them. I've got 9x minus 7 over x plus 2 is equal to what, y'all? 9x minus 15 over plain old what? X. Now we cross multiply. Shamalama ding dong. Look at there. Look at that. I know. She just said shamalama ding dong. What is she talking about? Cross multiply, folks. Cross multiply. I'm stuck in the 50s. What a fun time. I didn't live back then, but I think it would be fun. Don't even think that I do or did, because I didn't. Not old. Pretty young. Quit laughing. Really am. Hey, can you solve this? You better be able to. What are we going to do? Distribute on the left. 9x squared minus 7x. Do you guys agree with that? What am I going to do on the right? FOIL it out. X times 9x is 9x squared. X times negative 15 is negative 15x. 2 times 9x is 18x. 2 times negative 15 is negative 30. Combine your middle terms. 9x squared minus 7x on the left side is equal to 9x squared minus who? Minus 7x, my plus 3x, right? Sorry. I just want to see if you're paying attention. I meant to do that. Totally meant to do that. Now what? Just move things. I'm going to subtract 9x squared. What's going to happen? Oh my Lord, they're going to cancel out. Is that okay? Yeah. It's going to make things a whole lot nicer. Well, do I want to add 7x to both sides? No, because then I will have 0 is equal to something. So I'm going to subtract 3x. And look what we end up with. What's negative 7x minus 3x? Negative 10x. If you literally need to mark out those 9x squared, you mark them out. Minus 30. I'll be daggone. What am I going to do now? Divide by negative 10. Folks, I will be more than happy. What's negative 30 divided by negative 10? Positive 3. I will be more than happy to show you how I worked this problem out, finding common denominators. But it will make some of you cry. And I would rather not do that. It's not easy for a tree person to look at things from a forest perspective. But it's totally doable. And so much easier for the majority of us. Okay? Questions?
When you brought 15x over, how is it that 9 became 9x over x?
Okay, hold on.
Right there.
Because I was trying to get like denominators, correct? All right. What did I multiply to this denominator to get here? X. If I multiply it to the bottom, I have to multiply it to the top. Okay, good question. Any other questions? What do you think about that? Y'all know, this is taking me out of my comfort zone to step back and think before I jump in and start moving things and multiplying. And this is me. This is not in my comfort bubble, okay, at all. But when I look at it, I'm going, oh, so way easier. Way easier. Y'all know my rule of thumb. I don't care how you solve it, as long as what? As long as we all get to the same answer in the end, I don't care how you solve it. I will try to help you both, my way, forest way, whatever. As long as we get to the same answer and we understand what we're doing, that's the main thing. That's the main thing. Any other questions on that? No, I got it from here. Very first line. Very first line. Yeah. Any other questions? All right, let's finish up the notes for today. Yeah, questions? You're way too sleepy back there. You need to wake your hind end up. Yes, you can. Day number dos on rational equations. Folks, I'm going to show you two little special cases, short and sweet and to the point, and then you're going to work on your own, okay? It's more important for you to work on these problems than to hear me. Blah, 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 right? And you're nodding in agreement with love, right? Okay. All right, here we go. Helpful hint. And yes, we're going to write helpful hint in our notes with a smiley face. Because if it's helpful, it makes us happy. you better put a smiley face in your paper, on your paper, not in it, on it. Do it. Do it. All right, helpful hint. Some of y'all are going, I am not putting a smiley face on my paper. Get one denominator. Get like denominators. On one side only, to set up a proportion. Then cross multiply. And solve. Think trees. No. Think forest. Think forest. Think, step back and look at things and think, okay, could I move anything so that I can have one fraction equal to another fraction? Okay? So get your like denominators on one side only and then try to set up a proportion. That's the easiest way to solve any of these. But folks, if you don't have a problem finding common denominators, have at it. Have at it. Okay? It's not a big deal. That's your helpful hint. Remember, I was telling you to write x is equal to 2 when x cannot equal blah and blah, right? Everybody have this? Let's talk about extraneous solutions. Extraneous solutions. This is any solution. This is when we find those values, okay? Any solution that results in a 0 in the denominator is considered an extraneous solution. Any solution that will put a 0 in the denominator and make that number undefined, that's an extraneous solution, okay? And this may be the terminology that you see on an SOL. It's about 2 sentences in your textbook, which we never look at, okay? It is important, but it's just 2 sentences in your textbook, okay? Another bullet point we need to make, another point we need to make about extraneous solutions is it must be excluded, not included, from our solution set, which is just our list of solutions. That's what an extraneous solution is. It's kind of like a imposter, kind of. Maybe. It is, but it's not. It is, but we can't accept it. I don't know. Watched too much history yesterday. Anybody see the space jump? Did y'all watch it live? Anybody watch it live? How long did it take him to go up that far? 2.5 hours. I'd have taken a nap going up there too.
I don't see why we still have to test gravity that way. We know he'll fall.
We didn't test gravity. It's pretty. That was kind of cool. Kind of cool to be able to watch that. He was over 24 miles in space, in the air. That's, y'all, like the distance from here to Martinsville. Maybe to my house. There was a capsule that took him up with a balloon, a hot air balloon, wasn't it? And he was in a capsule. And then when he got however far, he jumped out. And he landed on his feet. And do you know what speed he accelerated? Over 800 miles an hour. Did he hear the sonic boom? Did it ever say? He did hear it? Okay, but they wanted to know, did he hear it? Okay, time out. All right, so extraneous solutions, you guys should never get off task. Boo you. Here we go. Y'all are so distracting. Here we go. I always try to stay on task. Always. I'm never off task. I know. Nobody watches the videos, Dante. I'm the only one that ever watches the videos. 2 views. Who views it the first time? Miss Perry. Who views it the second time? Miss Perry, just to make sure somebody can hear it. Maybe they can't hear it. Oh, yeah, you can. Who views it a third time? Miss Perry again. Nobody watches the videos. Why am I wasting my time? But just think of the wealth of information I will have on my jump drive. I could just sit at my desk and never get up. I could just play. All right, here we go. Do what? Play. All right. I'm glad that made you happy. What are we going to do with this? No, we are not going to run for the hills. Why do you want to put the 2 over on the right? I'll have the variable on the left side, and I'll have all the plain old numbers on the right side. Do you guys see that? Okay? We're trying to make it easy on ourselves, so I'm going to subtract 2. And it's going to give me 5 over y minus 2 is equal to 17 over 6 minus 2 over 1. Come on now. You don't even, y'all got calculators. I know what you're going to do. You're going to go parentheses 17 divided by 6, parentheses minus 2, enter, math frac, enter. And you're going to have, ding, a fraction. No, that's what you're going to do. But if you're going to tough it out, or man up, woman up, isn't 12 over 6 equivalent to 2? So that's actually going to give me 5/6, won't it? Does everybody agree? So my new right side will be 5 over 6. You guys agree with me? Can you take care of that for me real quick? Cross multiply that thing. Go. All right, here we go. So I'm going to distribute 5 times that quantity y minus 2 is 5y minus 10 equals 30. Add 10 to both sides, and you get 5y equals 40. Divide both sides by 5, and folks, what do you get? 8. Now, are we done? Am I automatically going to circle it and go, done? Nope. What do we have to go back and do? We've got to go back and check it, okay? So when you go back and check it, go to the original equation and plug in 8. 5 over 8 minus 2 plus 2, and see if it's equal to 17 divided by 6. All right, so when you check it, 5 minus technology is awesome. Thank you. 5 minus 8 minus 2, or 5 divided by. 8 minus 2 is 6, right? Plus 2 is 2.83 repeating. 17 divided by 6 better be 2.83 repeating. Are we good to go? Can we accept that solution? Is it an extraneous solution? Nope. That's straight up what my answer right there. Facile or difficile? Facile. Muy facile. See? No. You don't need to put where y does not equal anything, because the extraneous, understanding that those represent the values of the extraneous solutions takes care of that piece. So we don't have to do that. Okay? Yes? Because it's following order of operations. you need to go 5 divided by, parentheses, 8 minus 2. Because it's dividing the 5 by the 8 and then subtracting that answer, quotient, by 2. All right, here's another one. Any questions on that? I'm glad you find this humorous. 2 over z plus 1 minus 1 over z minus 1 equals negative 2 over z squared minus 1. All right. Think Forest. I feel like the Bee movie. What do they say? Thinking Bee, thinking, no, that's not it. Anyway, think Forest. What do you see in those denominators? It's a difference of squares. Z plus 1 and Z minus 1 is equal to what, y'all? Z squared minus 1. They're already equivalent to each other, aren't they? What's that mean? What do I have to do to that? What do I need to do? Can I move anything? I can't really move anything. But it's good that you're seeing that this is a difference of squares. All right, so we know we might have to go old school on this one. And I'm just going to factor my right side. Okay, that's all I did. What did I multiply to the first denominator? Z minus 1. Where do I also have to multiply that quantity? To the top. All right, I'm going to go ahead and write down the 2. What piece did I multiply to the second denominator, folks? Z plus 1. So I'm going to go ahead and write the 1 that's already there. And then does the negative 2 change, y'all? No, it doesn't change at all. Okay? At this point, every term in this equation has like denominators, correct? What does that mean? Drop the denominators. Put them on my desk. Drop the denominators. I don't need them now. Okay? They've served their purpose. Now we're kicking them to the curb. Do you have to be real careful here? Why do we have to be careful? Because there's a minus sign. All right, so we have 2z minus 2 minus the quantity. You know what? Stop. I'm not going to make a careless mistake, and I don't want you to. I don't care what you do on your homework, but I do not want you to make a careless mistake in the notes. We're going to distribute this now. Okay? 2z minus 2 minus this thing. 1 times any quantity is that quantity. Do you guys agree? That could be parentheses. I don't know why you square brackets. Okay? You with me so far? What do I have to do to that minus the quantity? I have to distribute negative 1. Okay? All it does is change these signs to their opposite, folks. And now we're going to combine like terms on the left. Which gives us 2z minus z is 1z. Negative 2 minus 1 is negative 3. And what do? Add 3 to both sides And we get z is equal to 1. You guys agree with that? Okay. 1. Does everybody agree with that? What do we have to do? We have to go back to the top and check it. We have to check it. Okay? So, let's check it. What's my original? 2 over 1 plus 1? Yep. Minus 1 over 1 minus 1 equals negative 2 over z squared minus 1. You guys agree? All I'm doing is substituting my value into the original equation. Does everybody agree with that? Z is equal to 1. We think it's our solution so far, but we have to check it. Okay? Anybody seeing anything going on here? 2 over 2 minus 1 over, oh, Lord. What's wrong? What's going to happen there? It's undefined. Oh, crap. What do I do? Oh, my God, did I do it wrong? What? Stop freaking out. Don't panic. Never, never, ever panic. First thing you always need to go back and do is make sure that you've copied the problem correctly. Okay, and we have. And then you go through and you see, have I made a careless mistake with my signs? Okay, did I? No, I didn't. That's checked. What does that mean, folks? If this yields an undefined term, oh, what do I do? I don't know how to make a scary face or like, oh, I don't know how to do that. Is it? What do I put? It is an extraneous solution. Extraneous solution at z equals 1. There are no solutions except for this imposter, except for this extraneous solution that we have to keep in. We have to keep it in the loop, kinda. Okay? Only way you would know that is if you checked it. And what if you got on a test or a quiz, z is equal to 1 and you circled it as your, what if it were a multiple choice? Holy crap. What would you do then? You're done. You're wrong. Can't even give you partial credit for that. Okay? But the extraneous solution is at. So there are no solutions except for the extraneous solution at z is equal to 1. Okay? And you're probably not going to see that written out that way on an SOL test, but if you see a no solution, you ought to know, hey, yep, something's up, okay? We're going to work another. This is one of those special cases, folks, that you have to be aware of. All right? Can we do another one? Are we ready? Ready? Maybe? Let's see how it goes. All right, here's another one. Let's look at this one. Look at page 124. You don't have to make reference to this. I'm going to in my notes. You don't have to flip. But it's in your workbook, page 124. Number 5, okay? That's going to be our third example. Mainly, I'm doing this because I don't want to assign it for homework, okay? 5 over 5 minus 5 is equal to y over y minus 5 minus 1. All right, here we go. If you step back and look at it, folks, what can we do with this? Anything we can do? I want to change this so that it has the common denominator, right? Okay. So we get 5 over y minus 5 equals y over y minus 5 minus y minus 5 over y minus 5. Isn't that right? Yeah? What do you have to do to that numerator, folks, so you don't make a careless mistake? Well, I'm going to put parentheses around it so I will distribute, okay? So that's going to give me 5 over y minus 5 is equal to, distribute the negative 1. I'm going to put y over y minus 5 plus negative y plus 5. Is that right? Okay. Kelly says yes, so I'm going on. Okay. It is right. And now what? Do I have like denominators on the right? Can I combine my numerators? Yes. Watch what happens. 5 over y minus 5 is equal to y minus y plus 5. What's going on here? The y's cancel out. And it gives us 5 over y minus 5 is equal to 5 over y minus 5. Anybody seen anything? Can't really go from there. Why? It's something equal to itself, isn't it? Is that a true statement? Is 5 over y minus 5 equal to 5 over y minus 5? Yeah. Even if you didn't see it, this is a true statement. STMT is how I abbreviate statement. Okay? Let's say, though, because I'm a tree person, I get caught up and I'm going, oh, look, I've got a fraction equal to a fraction. What can I do now? Cross multiply. All right, just watch. Let's say I didn't see it. 5 minus the quantity, y minus 5 is equal to 5 times the quantity, y minus 5. Oh, look, it's beautiful. I can work with it because I'm still thinking trees, right? I'm still caught up in the moving and the multiplying and seeing what I can do. Let's say you still don't see it. Distribute. Because there are some of you just like me and you don't want to admit it. And that's okay. I probably wouldn't admit it either. But I want you to see what could happen if you get caught up and you're doing the algebra and you're multiplying and you're distributing. 5y minus 25 is equal to 5y minus 25, and you still don't see it. Sometimes it could be right there in front of you and you still don't see it. So then we start moving things. And this is when you, if you're a tree person, this is when you panic and you go, ah, what have I done wrong? But, folks, is 0 equal to 0? Yes. What does that mean? If I have a true statement is not our answer. What does it mean if it gives us a true statement? Think back Algebra 1. If we were to have solved an equation that said -3 equals 4, how would you have solved that? What would you have written as your answer? And don't say -3 equals 4. How would you have solved that? What would you'd put no solution. And then in Algebra 1, you got to these equations that were 3 equals 3. How did you answer those? That's a true statement. 0 is equal to 0. How would you solve that? How would you answer it? What would you say? All solutions, expound upon that. If it can be all solutions, what kind of solutions? All real numbers. All real numbers. Folks, this is when you do that double R thing. Now, if you're still like, she don't know what she's talking about. Ain't no way. That is a real, I don't believe that. Look, my paper, even my own paper. I said, no, I've done something wrong. Ain't no way it's all reals. What do I do? How do I check it? Plug in random numbers. Choose a random positive number. And then choose a random negative number. Check it. Check it by using these random values. Plug it into the original equation. Okay? Oh, jeez. So check it. What is it? 5 over what? Y minus 5 is equal to y over y minus 5 minus 1. So check it with a random positive number. Let's go with 6. I'm just choosing a number out of my random bag of numbers. Okay? Now, here we go. 5 over, folks, what's 6 minus 5? 1. And then 6 over, what's 6 minus 5 again? 1 minus 1. Y'all, what is 5? Is this true? Does 5 equal 6 minus 1? Yes. Huh. Bless you. Maybe she's not crazy. Now let's choose some random negative number. Just choose any number. -4, okay? All right, so here we go. 5 over, what's -4 minus 5? -9 is equal to -4 over, -4 minus 5 is -9 minus 1. Calculator, put this in your calculator. Yes, sir. What about 5? So then 5 would have to be a what? It'd be an extraneous. Okay, well then it can't be all real numbers because it would be all real numbers except for what? Except for 5. Thank you. You're exactly right. Can't be that. Good job, Dylan. I didn't even catch that when I worked the problem. You're right. It can't be 5. Can't be 5. So it's going to be all reals except for no. That's right, because that would make that all real numbers. Now, would I have known that to begin with, or would I have known that when I'm checking it? This is one of those weird ones, y'all. I swear I don't think it would be on the SOL, but this is one that's going to bend your brain in half. Folks, when you put -4/9, -4 over -9 minus 1, you get the same thing, okay? They both work. But, weird problem. Special cases, folks. We're going to go about solving them right along, just like normal. But when you check it, you got to be aware of these weird things that happen. And that is just kind of weird. Okay? But you got to check it. Oh, if you didn't choose 5 as a random number, then you would probably have points taken off because I did the same thing on my own paper. But what if? What if? Not unless you look at the very beginning. If you look at it from the very beginning and go, okay, well, y cannot equal 5. If you want to look at it here at the very beginning and off to the side, you need to make yourself a note. Y cannot equal 5, because if it does, then it's going to be undefined. Okay? Question? I don't know the answer to that question. Let me find out the answer to that. Okay? Why don't we just do it from the get-go? I don't know. Right. Do it from the get-go. You're right. Okay? These are those weird cases. Like I said, it's not going to happen every time. If we work 100 problems, this may happen 4 times out of 100. But we have to take into account these 4 times that it does happen. Okay? Let me get back to you on an answer. Fair enough? You're probably right in saying, let's do this from the get-go, and that way we're safe. Okay? Check for those excluded, they're called excluded values from the beginning. Let's see what you can do with this. Since we're ending on such a positive note, let's go to the workbook. Okay? And I want you to look at page 124. I want you to look at 134. Work on those now. 1, 3, 4, 6, 8, 9, 17.